I'm Ruth Whittington, and I'm a wetland ecologist at Colorado Natural Heritage Program. During this training video, I'll discuss how to complete a soil profile description. This is found in section 5.4 of the Lentic AIM monitoring protocol, found on page 71. Soil profiles are an important part of understanding the long-term history of a wetland site. Soils within wetland and riparian areas may undergo periods of inundation, saturation, and resulting depletion of oxygen. By completing the soil profile descriptions, we can determine any hydric soil indicators shown in your soil profile and piece together evidence of what this hydrologic history has looked like in the past. Materials for this method include the soil data sheet, a sharpshooter shovel, auger, or soil probe, a soil knife or trowel, a tape measure, a squirt bottle, a Munsell soil color book, golf tees for marking horizon boundaries, and the Guide to Field Indicators of Hydric Soils in the United States, as well as the appropriate supplement for your ecoregion. To complete a soil profile description, first find a good location for the soil pit. Try to find a location within the most dominant vegetation community and/or geomorphic setting of a site. For spoke layouts in homogeneous settings, the default location is within the 5-meter radius circle near plot center. In other layouts, the pit should be located close to plot center in a spot with minimal disturbance. Next, excavate the soil pit to 50 centimeters using a sharpshooter shovel. Cut a rectangular area out from the soil, first with shallow cuts, slightly wider and as long as the shovel blade. After defining the area to be removed, go around again to completely separate the core from the rest of the soil. Do your best to make sure your soil pit is fully dislodged from the rest of the soil before pulling the shovel handle towards you to leverage it out from the ground surface. A soil knife or pruners can be used to cut through roots connected to the core in particularly stubborn soils. Try to keep this core as intact as possible as you remove it. If it begins to fall apart, set the excavated soil to the side of the pit, roughly maintaining the order of the removed layers. If an impenetrable obstacle is encountered, preventing excavation to 50 centimeters, indicate what impeded excavation. It is recommended that you try another soil pit in another location if this first soil pit falls short of the recommended 50 centimeters. Once you have a soil core removed, cut or shave a clean face of your soil profile away from the soil face before taking a picture of the removed core. Next, identify distinct horizons within the soil profile by indicating with golf tees where they start and end. Look for distinct changes in soil structure, color, and texture, and/or accumulation or loss of different soil materials. Be careful not to disturb the soil face until you have taken a picture. Tearing away pieces of the soil from the underside of the core can help accurately place the horizon's boundaries if you've not yet taken a picture. After determining the horizon boundaries on the soil core, it can be helpful to check these depth measurements against the horizon seen inside the pit in case the soil core became compacted during excavation. Once you've identified the soil horizons using your golf tees, put the tape measure up to the core and take a picture. Make sure to get as close to the core as possible and avoid pictures with shadows across the soil face. Cores that have fallen apart upon excavation may need to be reconstructed to represent the horizon order you observed. Review your image to make sure the picture is clear and the measuring tape is legible. Do not take pictures inside the pit unless you find it helpful as supplementary pictures to the picture of the core. Now that you've taken a picture of your soil pit, begin to describe each horizon. Start by taking the matrix color as well as any primary or secondary redox colors and their relative cover. Cover estimate guides in the Appendix N at the very back of the field protocol or pages in the front of the Munsell soil color book can be used to approximate the % of primary and secondary redox features. Color should always be taken on wet soils, so use your squirt bottle to wet the face of the soil if necessary. For soils with glade horizon, color may need to be read immediately to capture the soil color before iron compounds become oxidized in the air. Soil beds can also be broken broken open to expose new soil faces. Once you have taken the color of all horizons, determine which horizon, whether each horizon is organic, sandy, or clayey loamy, then use the appropriate method to determine soil texture. For mineral soils, use the texture by field flowchart on page 204 of your protocol to classify the soil into one of the 12 soil texture classes. For organic soils, classify by the degree of decomposition into fibric, humic, or sapric organic soil classes. Horizon comments can be used to add additional details about the horizon. For example, to say if the texture could be described as mucky mineral, or to provide additional information on the pattern of redox features observed. Finally, before backfilling the pit, measure the water depth. For all depth measurements, the soil surface should represent 0, meaning groundwater should be recorded as a negative value from the soil surface, and surface water should be recorded as positive values. Measure water depth after allowing sufficient time for the water to infiltrate into the pit and equilibrate with the elevation of the surrounding water table. You should also take the depth of saturated soil in the pit. If there is enough water in the pit, use the YSI to take a water quality measurement before backfilling the pit. Hydric soil indicators can then be determined using the soil profile description of soil color and horizon thicknesses. I will discuss various hydric soil indicators in more detail in another training video, but crews should follow guidance within field indicators of hydric soils in the United States, produced by the Army Corps of Engineers. You can also find shortened descriptions of these indicators in Appendix H of your protocol. In some cases, final hydric soil indicators may be determined after filling the pit if the soil profile description is complete and thorough. Before you backfill the pit, verify that all required fields have been completed and that descriptions of each horizon are detailed. Review the soil photo to ensure the soil face is clear and includes a measuring tape and horizon markers. After verifying the soil data sheet is complete, fill the soil pit back in with the excavated soil.